Thank you very much for joining this session. I know it's a hard time, we all had lunch, we're kind of getting sleepy. Hopefully this talk is not going to be boring for you. And my name is Demeter. I'd like to start with a quote that I think defines the essence of our cybersecurity industry. And this quote says, if you know the enemy and you know yourself, you shouldn't fear anything. And I think this is quite good, and we'll discuss about this a little bit later. So my name is Demeter. I graduated university almost 4 years ago. It's been a long time. Since then, I joined Kaspersky's lab, global research and analysis team, and I mostly do threat intelligence and big data. So I'm writing tools for threat intelligence that are helping my team further research and discover new stuff. And I'm also interested in big data, correlating stuff, and getting meaningful results. Also, if you don't know about my team, it's called Global Research and Analysis team. It was founded almost 10 years ago. This year we celebrated our 10th anniversary, and we are highly specialized in finding, analyzing, and protecting against APTs, advanced threats, or highly attacks against banks, governments, power plants, you name it. So, a little history. In our 10 years of existence, we managed to find a lot of interesting stuff. You might have heard about, oops, pointer is not working. You might have heard about DoQ, Gauss, Flame. You might have heard about Epic Turla. You might have heard about Carbanak. Who heard about Carbanak? Here. Perfect. So the leader got caught. It was a big win for us. And, you might ask yourself, hey, Dan, why do you only show 2017, 2016? Well, the answer is because 2017 wouldn't fit in the slide. We managed to uncover more than 100 APT groups, different APT groups, and it couldn't fit on the screen. So yes, it's that many. If you want to catch up with our latest research, feel free to check our securities.com. It's our blog post where we post our newest research, newest findings, but it's not totally new, mostly because, we don't publish most of all our stuff on this website, mostly because we have our private reports, and actually we are publishing new research every week. So our private reports, they don't go here, but we also published our latest stuff on this website. But during our security analyst conference, which happened this year, two gentlemen way smarter than I am, they presented their idea of the information war. And this information war, they said, has three parts. It has the mass opinion manipulation, which we're not going to talk about today. And it has two other components, the cyber espionage and cyber sabotage. Those two components, they both use only one in a specific code, and they use malware. Well, they use malware in order to gain persistence, in order to able to enter new networks or to exfiltrate data. And today we're going to talk about malware. And most importantly, we're going to talk about finding malware. Does this piece of code look familiar to you? It's kind of like C code type. Nobody? Okay, we have somebody here. Okay, so this piece of looking C-type code is called Yara. With Yara, basically, it's an open source tool. Its creator calls it the Swiss Army knife for pattern matching. And it basically allows you to write specific and advanced rules to match files. So let's say you have one binary, you have one sample, and then you can write specific rules in order to try to find similar samples that are kind of identical with the same sample that you're analyzing. And basically, you can use Yara, you can download, you compile it, and then you can run Yara over a collection of files which are not, let's say, clustered or you don't know what they are. And then you can try to see if those files match your Yara rules. And then you can find similarities, code similarities between those two samples. And basically, you can say those samples are from the same family, are from the same APT group, or not. Well, there's a problem with this. It's the problem that you need to hunt in the wild. You can write the best Yara rule, but if you don't know where to run the Yara rule in, or you don't know where to search for, or you don't have where to search your Yara rule, then it's kind of useless. So most of you might be using VirusTotal. I'm using it a lot. In VirusTotal, there's an option. There's a button called VirusTotal Intelligence. And in that intelligence, you can run your Yara rules over their collection. It's called RetroHunt. And basically, VirusTotal allows you to run your Yara rules over their entire collection, which is huge. It takes some time to scan it entirely, but you get your results. You can get your matched files by your Yara rule. Well, that's pretty good. That's pretty good about this, but there are some issues. First of all, you have to upload your Yara rule on VirusTotal. What happens if you have a TLP read only for your team Yara rule? Well, you can't actually upload it on VirusTotal. Secondly, their collection of files, it's theirs. What if you have your own collection and you don't want to upload them on VirusTotal, but you want to scan them in a distributed, dynamic way like they do with RetroHunt? Well, because of these issues, we decided to create our own scanner. And it's not called Dolores, although I wished, because it's my favorite character. It's called Clara. So Clara, basically what it does is a distributed Yara scanner. It allows you to submit your Yara rules on a web interface. You submit them, you click run, and then they get distributed to multiple servers. Servers start scanning the file repositories they have with your Yara rules, and you get back your results. Furthermore, you have the option of implementing groups, such that you can have a group for your team, you can have a group for your customers, you can have a group for whatever you prefer. And in those groups, people are allowed to scan different files. And basically, it's a neat way to just fire a Yara rule, upload it on the web interface, and you get the results back. You don't have to run it on your computer. You don't have to execute any command, commands from your terminal. Although I'm a fan of terminal, like running commands in the terminal, but some people, they just prefer to, and it's easier to just upload them on the web interface. So you might say, okay, Dan, but, why should I use Clara? Well, if you have your Yara rules and you want to check against if they're correct, if they match some files, if they don't fire false positives, you might want to do it, because the cycle of creating a Yara rule is quite complicated, because you first need to create a Yara rule, then you have to test for false positives, then you have to tweak it again, make it better, use some more relaxed options, or add some more conditions, and then run it again, and then when you're happy with your rule, you have to run it over your collection of samples, unknown samples or malwares or whatever. Then another reason is that you might face some problems if you're running locally on your laptop, especially with collections that are higher than that are big in size, like 1 terabyte, 2 terabytes, 5 terabytes. You can't actually run this one on your laptop. mostly because it takes a lot of time, and secondly, because you don't have a lot of storage available for you. So the solution would be to actually run it in the cloud. As I said, like RetroHunt. Then you have another option where your Yara rule, which is amazing, it's like best Yara rule ever, didn't hit on any files. Does it mean it's a bad Yara rule? No. It means that right now you didn't match anything, but you might match something tomorrow. You might match it in 1 year. So basically what you want to do is, and one possible scenario would be to have all your files, suspicious files from your organization, your SOC center will collect them, you dump them in one of your servers, and then you periodically scan those files with your Yara rules. And let's say it might not match today, but in next year, your Yara rule that you created 2 years ago might match. And you'll see, oh, this is a sample. We got hit by this APT, and now they're trying to hit us again. So that's like pretty cool. Furthermore, you can have your results shared in a nice way on the web interface. So instead of like sharing Yara results by email, which is like so 1990s, you can just send the link on Slack, and then like your colleague from the same team can just like click on the link and get the results. And lastly, you can also run Yara trainings like we do. Basically, with people, they don't have to install Yara on their laptop. They can just upload the rules on the web interface. This is also useful for people who don't know how to compile Yara, and you might end up like with issues like .NET is missing, or like some library didn't compile correctly. So basically, you can have like a clean web interface where they just fire the rules. So, okay, let's talk about like the project itself. How does it look like, briefly? Basically, it's Python, an SQL database, and of course, it's using the Yara binary. We didn't modify the Yara binary. Basically, you can just download it from GitHub and you can run it. In terms of the architecture, it's not super complicated. Basically, we have like a dispatcher and multiple workers. They connect to the dispatcher. Dispatcher gets the jobs from the database, and the users can submit jobs, and you can create groups and jobs and whatever. You can create them on the web interface, which then changes the database. And whenever a user submits a new job, the job gets inserted into the database, and then the workers will ping dispatcher, and dispatcher will say, okay, let me check the database, checks the database, and says, okay, I have a new job for you. Here it is. I have assigned this job for you. When worker finishes the scan, returns the results back to dispatcher. Dispatcher notifies by email the user, and you have your results on the web interface. So it's pretty simple. The idea is that you can add as many workers as you want. You can have unlimited workers. And nowadays, with the increasing cost of supercomputers, like it's better to have like 100 like not so powerful computers rather than just one powerful computer. So that's pretty neat about this. So I wouldn't be telling you this and I wouldn't be presenting you this project if you wouldn't have the chance to play with it. So basically, this year we open source the project. You can check it on GitHub, and you can install it in your infrastructure and run distributed Yara rules. So I think this is pretty good. In terms of installing it, we run it on Ubuntu. We ran it on Ubuntu. It also works on Debian, Ubuntu 16 or 18 LTS. Basically, you need Python, you need supervisor, and Python with virtual environment. You need to have the same setup for the worker, plus the Yara binary, and an SQL database. We recommend MariaDB, but you can also use MySQL. Up to you, doesn't matter. So as I said, it's a worker dispatcher paradigm, and it has a web interface, which looks like this. So whenever you log in for the first time, you have a dashboard, and in the dashboard you have like, unfortunately, I can't point. I don't know why it doesn't work, but yes, it works. This. So you have the dashboard. You have like create jobs and new job. And whenever you go like on a new job, you can just paste your rule here, and you have those repositories to scan, which are those things here. And just a little info about repositories. Each server can have multiple repositories. When I say repository, I am actually referring to a folder that sits on the data storage for one server. And basically, you can have multiple folders with different names. And you can see, like, on one of our workers, we have this clean folder, and we have this SIS folder. So basically, these are the repositories. Whenever you press submit, like you press submit here, basically, those rules are being fired. They will be picked up by the workers. And then when they finish, they just tell you, like, it's scanned in 8 seconds. This is your rule. This is repository, and those are the results. In this case, we didn't have any results, but basically, if we matched any files, you would have their MD files in here, and you have the Yara results in here. Okay, cool. So I talked about repositories. One important thing, if you want to install this one in your infrastructure, is that you have to be careful when you're setting up your repositories, because you need to set up a repository control file. So please check the instructions, because you need to set up a repository control file. And this repository control file has also some other features, which we're gonna be discussing next. It has some advanced features, and some of them are here. And basically, I'll go through them really fast. So the redirect paths feature allows you to have a repository in one directory, but rather scan another directory. So think of it like a symbolic link in Linux. You know, like this is the repository, like mount storage, virus total samples. And then basically I say, no, I'd like to redirect a scan to mount NAS, Clara bigger collection. So basically from this, the worker will scan this one. It's like a symbolic link, exactly like a symbolic link. Then you can search for hashes. So basically each rule might hit on different files. And then you can search for this MD5 or SHA-1 hash. How many rules did match this file? And then basically you can search for multiple hashes, and you can see multiple rules that match those files. This is useful when you want to see if 2 Yara rules generate the same results. And you can compare and do whatever you want with them. Then you can have shareable links. Shareable links are useful if you want to share your rules with somebody else. And basically you can see here, you have like a link, and then you can copy this link and you can provide it to other users of the platform, and they can see your rule, regardless of if they're in the same group with you, if they have the same access as you have. So this is pretty cool if you share rules between you. So basically this was it, Clara in a nutshell. But it wouldn't be useful if we don't try to optimize it as much as possible. So basically we try to get the most out of it. So of course, the first optimization would be the server performance. And I think the most important one are disks. If you're running with spinning disks, you won't get a lot of performance out of it. So instead, we decided of running with SSDs. We have them like in a server, we have like 8 SSDs in a RAID 5 configuration. And on top of that RAID, we decided to use an XFS file system, because XFS is pretty fast with reading, also with writing, but it's not a lot of wear and tear on the SSDs itself. Mostly because if you're doing a lot of scans, you're not writing a lot, you're reading. 90% of our operations are read operations, so that's pretty cool. So these are the servers. This is the SSD server. This is the database server. Like SSD is on top, database on the back, below. They are super micro servers. I know, crazy stuff. We checked them, nothing suspicious, but you never know. And we got 3 gigabytes per second, 3 gigabytes scanning speed, which is pretty impressive. We hit the RAID read speed, so unfortunately we can't get more out of that RAID. But basically, we managed to scan 10 terabytes in 30 minutes, which is pretty impressive, of course, with caching and other techniques. But mostly with that setup, with the server setup, I think 30 minutes is pretty okay in order to find for new samples. We have over 30, since we deployed, we have over 30,000 jobs, and they all worked okay. We distributed it with multiple servers, as you saw in the picture, but we also have multiple servers. All of them are SSDs. And I think it's very important when you're setting up the server, no matter if it's like SSDs or spinning disks, to have the file system and the file system properly configured. And this implies that you need to set up the stripe correction, the stripe, RAID stripe correctly, and the number of disks. So basically, in our example, in our situation, we have like a 256 kilo stripes, and we have like 7 data disks and one parity disk, which is like RAID 5. And of course, the mounting options in order to try to get out of the most speed out of it. Okay, so basically, the future plans, I'm the main developer of Clara. Our future plans are to set up the web interface, to set up the web API. Basically, the API allowing you to to run the same commands and to do everything as you do as like a web user. You can do it using an API. And this means that you can set up tasks, that you fire Yara rules over your collection, and you have another robot that feeds new files into your servers, and then you can scan the files. You can check new Yara rules that you receive from your local certs. You can check them against your files, and you can do other cool stuff. So this week, I'm gonna be releasing the API specifications and the API code. And as a gift for you, because you attended our session, if you want, come talk to me or send, come talk to me, I'm gonna be around here. You can also contact me on Twitter. I can create an account for you on our Clara server with our virus collection. Well, don't think that is Kaspersky's huge virus collection, because I can't provide that, mostly because it's like super huge, but we have a smaller collection of 10 terabytes with most of our interesting files and interesting attacks that you can scan your Yara rules against. So please come by if you want to test it out. Also, there's a web interface. Basically, you can see it in action without installing it yourself. So going back to my originally quote, I think that it should be slightly changed to this one. And I would say that Yara is the future. And if you didn't start already writing Yara rules, you should. If you want to search for the project, you can search on your favorite, on DuckDuckGo or your favorite search engine, search for Kaspersky Clara. Great. You can follow my Twitter, or you can join our chat on Telegram, where we discuss about updates or improvements to Clara. And with this being said, I would like to thank you for watching my presentation, and I hope it was interesting.
Hello, nice talk.
Thank you.
May I ask, Clara is scanning just files, or you plan to scan also some metadata in some DB, like sequences or n-grams?
Okay, so basically we are using, Clara is using Yara. And basically what Clara does, it feeds a file, like physical file, to Yara. If Yara can do what you're saying, then Clara can also be implemented to do that. Now, n-gram, we are actually using n-gram, but we have like a modified system, which is not available for, it's not open sourced. So whatever Yara can do, Clara can also be programmed to do that. Thank you.
And the second question,
yeah, sure.
I saw that the most of the code base is in PHP. Why have you chosen this?
Most of the code base is actually Python, but the web interface is PHP. This is because of legacy reasons, mostly because we had an older system, web interface, that it was written in PHP, and for another project, and basically I just use that for the web interface. But dispatcher and workers are in Python. So basically you can just install them on any operating system. And I want to rewrite the web page in PHP, but I just wanted to have it something useful that people can use.
Okay, any more questions?
Hi.
Hello.
Do you have something to manage the similar rule in case some of your colleagues create a new rule that is similar to you that you created previously that say, hey, there is another rule that is matching something?
So there are other projects that are actually meant to organize Yara rules. Currently in Clara, there's no option to have like similar Yara rules or to see if others wrote the same stuff. Mostly because we decided to just have this project. Like you fire a rule on the web interface, you get the results back, and that's it. Yeah, but there are other projects that are actually used to cluster, to organize Yara rules. But the answer is no.
Okay, any further questions?
We have another question there.
If I understand correctly, the workers need to have local access to the collection, to the malware collection?
Of course, yes.
So there's no pull mechanism to fetch a Yara rule and then a file and then from the dispatcher?
So, so workers have the local files physically in their data store. Workers, they connect to the dispatcher, and dispatcher gives them the Yara rule that they have to scan.
But the dispatcher does not provide the file.
Dispatcher does not provide any files.
So file management you need to set up separately.
The files, you can have your robots feed the files to the workers directly. So there are no files being sent over the network. You have the local collection of files in your workers. You feed them as you want. You can have like a distributed file system on the workers, up to you. Then what dispatcher does, it only feeds the Yara rule and it feeds an ID. So basically the worker comes back and says, hey, I finished the work with these Yara rules. These are the results. This is the ID of the job.
Okay. So it's up to the worker to decide which files to scan.
No, it's up to the user to decide which files to scan, because in the user, you select those repositories, if you remember. You select which repositories you want to scan.
Right, and those repositories are locally present on the workers.
Yeah. And multiple workers can have the repositories. This is what we're doing. We have like 5 workers, and all of them have /clean repository, which you can
so
see.
file management is a separate process outside of the Clara system.
Sorry, I didn't understand.
So file management, so distributing the malware among your workers is up to you, really.
Of course, and we designed it like this. Basically, it's up to you to distribute the malware, the collection, the samples on each workers, up to you how much, however you want.
Okay.
There are some plans on trying to get the option of, because you might run into some issues, like you have a hit, yeah? How do you get the file? Mm-hmm. And basically, we have a different system that we can fetch the file by its MD5 or SHA. But if you don't have that system, it might be a feature of Clara to just say, hey, I want this file with this hash. And then basically dispatcher goes to the worker and says, give me this file, and the worker it is back, and then but it's not implemented.
All right. Okay.
Okay.
Thank you.
Any other questions? I think there are none.
Okay. Thanks, Dan.
Thank you very much.